And welcome to the next video where we are going to look at the repeat until loop. So if we open up our notes here again, we can go back to our loops and see there are three types of loops. We've already looked at the counted loop to loop through a set of steps for a specific number of times. Now we're going to look at this post-test or the unguarded loop. This is the loop that actually tests the condition at the end of its instruction. So it's going to test the condition after everything has been done. So we need to work out what we can do that we can run through and then test a condition. And the easiest thing would be a simple little guessing game. So let's go to our pseudocode. And we're going to ask for a guessing game. I'm going to put the mic in shot, but that's all right. So we're going to ask for a simple little guessing game. So we're going to start our program. And what we want to do is we want to generate a random number. So we're going to generate a random number. Then we're going to ask the user to try and guess what that number is. And we're going to keep looping through until the user generates, until the user guesses what that random number is. So the first thing we do is generate a random number. Then we will ask the user to enter a number. And then we will say if the user number equals or double equals the random number, no capital there, then we will simply display to the user right correct. Nice and simple. If the user doesn't get it right, else, then we will say incorrect. And try again. And that is the simple program. So that's our simple little program. It's just going to generate a random number, ask the user to enter another number. If those are the same, it will write correct. Otherwise, it will write incorrect. Now, you can start off programming this, and this wouldn't be too difficult to put together. But what we want to do is we want to remember that we are trying to loop this through. So instead of just writing this up, we're going to add an extra layer. So we're going to start, and then we're going to loop, and we're going to loop it until we hit this condition, until the condition will be the same as this if statement. So until these things are the same, until the user gets the right number, we're going to keep looping. Now, we put this condition here. We use a unguarded loop or a post-test loop because this will always go through at least once. So because this will always run through at least once, then we can hit this number and we can go back around and around and around again. That is the pseudocode for what we want to do. It's nice and simple. There's not too much ambiguity there. We've just got this nice little flexibility. But we start, and we can see here by the way that we have placed our indents, our spacing, that our loop comes in this spot and our until goes in that spot. So we know this is the stuff that is looping. This is the bit, all of this that's inside between these two is what's actually going to be repeated. So let's turn to our code and see what we can work out. So we're going to open our new program, and we're going to call this program repeat loop. So we go and type in our program, and we save our files because we have to save everything to make sure that we don't forget. And then we're going to users CRT so that we can bring in our controls, and we start looking at our variables. Now, in our variables here, 1, 2, 3, 4, 5, we will actually need one. We will only need one variable at this point. No, we won't. We will need two variables at this point. We will need whatever the user's guess is, and we'll need the random number. I'll tell you what, we haven't done random numbers yet, so let's leave that aside for now, and let's just try with a set number, guess. And we're going to define this again as an integer, simply because it's the easiest one to use. So we're going to define our only variable in this as guess, which is going to be an integer, and we will begin our code. Now, our code is actually rather simple. We're going to write line to the user, asking them to, please enter a number. Now, the advantage with our code is, as we saw in the last loop, we can start writing things down and we can add layers as we go. We're going to read line. You've all done this part before, so I don't need to go through it in too much detail with you. We're going to read our guess. And we're going to set our guess for the start. Just for this first bit, we're going to say if guess equals 5. We're going to set our guess to be 5 to start off with. Then we're going to come back here. 1, 2, 3, 4, 5. Right line. And we're going to say correct. So if the user gets it right the first time, they're going to simply say correct. And we don't put a semicolon at the end of our if statement. Remember, our if statement doesn't require a semicolon there. Else, only use a semicolon if we are using begin and end. So we don't use a semicolon there. Else, 1, 2, 3, 4, 5. Incorrect. This one does need a semicolon. And then we simply read line to, so that we are not going to just close the program and end with our full stop. So let's give this a try, shall we? Let's see if this will run just the first time. And remembering my computer will run it twice, so we're going to enter number 3. Incorrect. That's what we want. So we hit enter, and the second time when it runs, if we put in 5, correct. Good. That's exactly what we want the program to do. So this program is working well to start with. Now we're going to add our loop in. So now we're going to add our loop just so that we can keep allowing it to repeat until we want to. So we can open our new line here, and we type in repeat. Now, these are in your notes. Going back to your notes here, we just drop down a little bit. We can see that our programming code, as we have it in Pascal, we say repeat, and then we put all of the code we want to repeat in here, and then we use the until keyword, and we define our condition after the until keyword. So in this particular example, we're simply counting from 4 to 20 by 2s, so we will repeat this until the counter is less than, that should be an equal sign, is equal to 20. And so this will be our little example. So in this one, we're going to repeat, and now we need to space our code out a little bit more because we are adding in an extra layer of our encapsulation. So we're going to repeat this until, and it's going to be the same thing. Guess is equal to 5. So until our guess is equal to 5, until the user guesses the correct number, we're just going to keep repeating. So let's give this a try. We will program and run. Enter a number. 3, no. 1, no. 2, no. 4, no. 700 and 879, no. 3, we've already done 3. 5, correct. And our program ends. So our program now repeats and repeats until we enter the number 5. So that's exactly what we want our program to do. However, because we want to add some layers to this, and because I know that you guys have all been reading the extra Pascal things, you guys have all been studying the Pascal, we're going to add a random number in here. So, and to guess, we're also going to add RND number. So we're going to add a random number in here. Now, there are a couple of different ways we could do this. What we want to do is we want to have our random number defined before our loop. So up here, we're going to define our random number, and we use the equals, the colon equals operator to define a random number. And when we have a random number in Pascal, we have to we use the command random. Now, random is a keyword in Pascal. It's a Pascal program word, and it will allow us to set a random number. But if we leave it like this, unfortunately, it will give us a real value. It won't return a value of an integer. It will only return a decimal space. So we have to pass it the parameter 10 to say that we want a whole number between 0 and 10. So now we have a random number generated, and then instead of our guess being equal to 5, we want our guess to be equal to the random number. Now, I'm going to cheat a little bit here just because I can. So after the first loop that we come through, before our until, I'm going to write the number in, just so that we can see what our random number is. I want it there, and I want it here. So now we can actually check and see what our random number is. Let's give this a try. Run the program. Please enter a number. Now, notice that it has not displayed the number first because we are at this right line first. So we haven't actually seen this yet because we're only up at this right line here. We aren't at the next one. So we're going to say 3. Incorrect. The number, as it turns out, is 5 in that case. So let's just let the program reopen. So 3. The number, as we said, is 5. 6, no. 1, no. 85, no. 6, no. 5 is correct. So now we have a random number that generates a random number up to 10. And remember from last year's work, for those of you who weren't in my class last year, programming languages do have numbers that they like to favor. Programming languages do have numbers that they really like to hold on to and favor in a big way. In my experience, most programming languages will favor the number 5 anyway. That's why we use 5 as a default programming number. But in the experience that I've seen, most programming languages will have a number that they will favor, and 5 seems to be a big one. It seems to be 3 in C++, it seems to be 5 in Java, it seems to be 5 in Python. So there are different numbers that you will find will be favored. So remember from your physics, there's no such thing as randomness in the universe. But for now, this is how we will do a repeat loop. So we will use these loops. And you could really, with this particular example, you could swap this out for a while loop, but there will be some things, as I said, that you will want to have happen regardless as to if that condition is met or not, once at least. So that's the end of our repeats, repeat untils. Come back with me in a moment and we will do some while loops. If you have any troubles, please feel free to email me or contact me through Google Classroom. Catch you later.